Welcome to VW 7.7 Part 2. Today we're going to be talking about how to graph the cosecant and the secant graph. So first, look at this graph right here. This is the graph of 2 sine 2x, and we're going to use it to graph 2 cosecant 2x. Now what you have to do is think about the relationship between sine and cosecant. Cosecant is the reciprocal. So what you have to do first is mark everywhere the sine graph is 0. Okay, so I'm going to put step 1 here. Mark the zeros. Because what happens if the sine graph is 0, to the cosecant graph, the reciprocal of 0 is undefined, which means these zeros become asymptotes. So draw your asymptotes like that. The next step is you're going to mark your max and min values. So notice how each peak and valley there. So now we've marked all those. Now what's going to happen is those max values for sine at the top and bottom, max and min, when you flip them, they remain the same. Because if you think about the circle, the max value of the circle for sine would be at the top, that's 1, at the bottom it's -1. And notice how if you flip those, the reciprocal of 1 is 1, the reciprocal of -1 is -1, which means if you take the reciprocal of the max value of any sine or cosecant graph, they're equal. So what happens is that these points are actually on your new graph. And again, maybe I'll leave them in red so it's a little more clear. Then, if you really focus in on this part right here, all these values are going to flip. They're going to become the reciprocal, so they become parabolas like that. And there we have it. That's how you graph a cosecant graph. Now, a couple of things to write down here. Here to here, that's 1 period. Okay, right there. So 2 parabolas, that's going to be 1 period. And the domain and range are going to be a little bit different, a little bit harder than 10. Let's start with the domain. All x such that x cannot be. It's the same idea. You can pick any asymptote. So in this case, I'll pick pi over 2 because that's right there. Plus, however, look at the distance between each asymptote. We want to focus on this distance right here, or this distance right here. In this case, it would be pi over 2. So that's why we're going to write pi over 2 k. So again, this first part, that's any asymptote. And some people like putting 0, so I'll put 0 for this one just to show you the other answer. And this next part, this pi over 2, notice how that is not the period. The period here is pi, this distance here, which means this is actually half the period. Now the range, we're going to use interval notation. -infinity to, look at the min value that was on the sine graph, -2 inclusive, union 2 to infinity. So that's how you write everything except for this part in between the parabolas. And there we have it. There's our domain, range, and the cosecant graph. So now let's go to the example right below it. Let's actually try to graph it. Let me show you how this works. It's very similar to sine and cosine. We'll start by identifying your amplitudes, that's 2. the period formula is still 2 pi over b for these, so nothing really new. So 2 pi over 1, that's 2 pi. And you're going to graph it the same way with your t. So make your t. Now the difference is going to be, you don't want to mark the top of the y-axis, mark like in the middle like that. And then same thing, 1, 2, 3, 4. The fourth tick mark is your period. This point should feel pretty familiar. That's 0 to -2. Except what I want you to do now is graph a skeleton of the sine graph. So imagine this were 2 sine x. It would look something like this. The reason we're doing that is because we want to use the technique we were talking about earlier to graph the cosecant wave. Mark the zeros. So the zeros are here, 1, 2, 3. Those become your asymptotes, like that. Mark the max and min values, and those become your parabolas. And look how easy that was. For labeling, just label these 2 points in here. That's pi over 2, 2. 3 pi over 2, -2. Let's try our domain, x, such that x cannot be 0 plus half the period is pi, so pi k. And the range is -infinity to -2, union 2 to infinity. And there we have it. Let's try to do a cosecant, or sorry, a secant graph. So look right here. You're going to follow the exact same steps. Mark the zeros here. They become your asymptotes. Mark the max and the mins. And draw your parabolas. So you'll notice it looks pretty similar to the cosecant graph, because sine and cosine are so closely related. It's just shifted. However, when you're graphing this, most books are going to focus on this part. So let me do this in purple. For our class, and this is really pretty much every math class, this is going to be considered one period. Right there. That's going to be one period. So notice how it is still 2 parabolas. It's just broken up. So half plus 1 plus half. Think of it that way. Now the domain here is going to be a little bit different from the cosecant, but similar pattern. For secant, you don't use 0. So just use that first asymptote. So in this case, it's going to be x such that x cannot be. So since this is 1 right here, that first asymptote must be a quarter. And half the period would be 1/2. And there it is. So again, notice how for secant, you're not going to have 0 in there. That's because there should always be a intercept on the 0 line. So you want to avoid using 0. And the range, that's going to be pretty much identical to what we just did. -infinity to, that looks like -1/2, union 1/2 to infinity. There we have it. So let's try our example right there. I'll draw a line to separate it. Step 1, our a value is 3. Our period is 4 pi. Let's graph. So here's our t. Let's put 0, and don't forget this part. You want to make sure you have your a value kind of in the middle. 1, 2, 3, 4. Fourth tick mark is 4 pi, which means every tick mark is pi. And now I'm going to sketch my cosine wave. Now notice how it's negative here. So that will impact how I sketch the wave. So I did in red. Once you're good, you can just put those 5 dots. You don't really need the skeleton once you really understand what you're doing. And then let's graph it. So there's going to be an asymptote at pi, asymptote at 3 pi, and draw your parabolas. Let's label 0, -3, 2 pi 3, 4 pi, -3. Let's do our domain and range. All x such that x cannot be pi plus half the period 2 pi k. And the range would be -∞ to -3, inclusive 3 to infinity. All right, that's it.